right, homework out. Books open to page 252. And you did page 252 to 253, numbers 1, 3, 5, 15, 18, 25, and 27. I'm going to have that out so I can come by and check to make sure that's completed. Homework? No? Our judge. Working with finding areas of various plane figures. And want to make sure we have the formulas memorized. Just kidding. All right. And most of them we've worked with quite a bit. Trapezoid still tends to give us a little trouble, Kendall. What's the formula for the area of a trapezoid? There we go. TR equals 1/2 h times the quantity b plus b prime. Rhombus has given us just a little bit of difficulty as well. Genesis?
RH equals 1/2 B1 B2. No, the 1/2.
Ethan, helper?
Rhombus equals 1/2 D1 D2.
1/2 D1 D2. Remember the diagonals of the rhombus there. And a right triangle, Jamie, we don't necessarily need right triangle because we have regular triangle, but you know.
T with RT at the bottom then equals 1/2 leg 1, leg 2.
Good. T sub RT equals 1/2 leg 1, leg 2. Most of the other figures we've got down pretty well. Let's go and take a look at the homework here. And number 1, read that for us if you would, Quentin.
Find the area of an isosceles triangle with 16 inches and the length of the leg 13 inches.
All right. It's important to remember, Dalton, that for an isosceles triangle, that means what? What does isosceles mean?
It's got 2 equal sides.
2 equal sides, and we call those equal sides
Legs.
legs. So if the base is 10 inches, yeah, we have a special guest today, and one of the legs it says is 13 inches, well, we know really then, Dalton,
The other side's 13.
the other leg is 13 inches. Impeccable logic. You must have had a great geometry teacher last year. And it says to find the area. Well, in general, Audrey, if I want the area of a triangle, I need the formula. And T equals 1/2 BH. Melvin, we have, obviously, in the picture, which of those two things that we need?
The base.
The base, right? The base is easy, so I mean, it's right there in front of us, 10 inches. So clearly what we're missing, Melvin, is the height. The height or the
Altitude.
altitude, right. And of course, we remember, Chris, that altitude means
vertex line to the base. Bisects the base on isosceles triangle.
it does happen to, yes, we're going to get there. But in general, altitude means, Chase?
I know.
Oh, here was your chance, class.
Perpendicular.
Perpendicular. Right, so we need to draw our altitude so it's perpendicular. Now, Chris mentioned something important I was about to ask. In an isosceles triangle, what does the altitude do to the base? And you said it bisects. So if the base is 10 inches, each piece of the base is going to be 5 inches. How does that help me to find the length of the altitude? Because without the altitude, I can't find the area. Kendall?
You can do the Pythagorean theorem.
Yeah, I've got a right triangle right here. I've got a side of 5. I've got a hypotenuse of 13, and the other leg is my altitude. And when we use the Pythagorean theorem, anyone from your homework, we find the altitude to be 12 inches is what we should have there. And so once we've got that, we can find the area. And what did you get for the area there, Jamie?
60 inches squared.
It's 60 inches squared. Here I take half of maybe the 12 to get a 6, and then 10 times 6 gives us the 60. How many have the 60 inches squared for number 1? All right, several of you did. Questions from those who did not. All right, number 3 says the altitude of an equilateral triangle is 9 inches. Of course, we know equilateral means what, Chase?
What?
Equilateral triangle means
All the sides are equal.
all the sides are equal. And if all the sides are equal, class, that also means all the angles are going to be equal. And it means all the angles are going to be exactly how big, class? 60 degrees. And because we know that, our brains should immediately be thinking, ding, 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 class, 30, 60, 90. And so it tells us the altitude. And once again, we know that the altitude, since it's equilateral, it's also isosceles, going to bisect the base here. We know that we've got our 30-degree angles here. It tells us the altitude's 9 inches, but I'm thinking 30, 60, 90. In this right triangle, the 9 inches, this altitude is normally represented how? Quentin?
X times square root of 3.
X times the square root of 3, because it's across from the 60. Now across from the 30, just this piece would be represented, class, X. And then the hypotenuse here, this full side of the triangle, would be represented, class, 2x. As would, by the way, this side, as would, by the way, that side, right? So the question comes, what's x? Or better yet, if I'm finding the area of a triangle, which uses what formula again, Genesis? Just triangle.
T equals a half.
This time I know the altitude, 9 inches, and I'm missing the base to find the area. Well, the base is represented 2x. If we can find what 2x is, I can plug it in for the base, I can find the area, right? But to find 2x, class, we must first find x. And if x squared of 3 is or equals 9 inches, then to find just plain old x, I've got to get rid of the square root of 3, class. That is, I've got to divide away. Let me make it a little bit bigger here. I've got to divide away the square root of 3. Of course, what we do to one side, class, got it together. Are we allowed to leave a radical in the denominator, class? No, that's irrational. So we're going to multiply top and bottom by square root of 3. And in the top, Dalton, we get? We're multiplying 9 times the square root of 3. What does that give us?
3.
9 times the square root of 3. And I'm just picking on you now. All right, what about in the bottom, Dalton? We got a square root of 3 times square root of 3?
3.
That's 3. Square root of 9, which is 3. And we can do a little bit of reducing here to end up with,
3 square root of 3.
look at him, look at the memory, great job. 3 times the square root of 3 inches. Now that's x. But remember the base is 2x. So what should we plug in for the base here, Dalton? Which, since x is 3 square root of 3, then 2x would be?
3 square root of 3. 9
Oh,
square root of 3.
I was trying to give you a chance to show off there. It's okay. All right, it's been a long time for him. It's been a year, in fact, since we've done this. I help in class?
6 square root of 3.
6 times the square root of 3 inches. And I would like to take half of one of these values. Well, half of 9 is annoying, but half of 6 square root of 3 isn't bad, class. 3 square root of 3, and when we multiply, we end up with, anyone?
27 square root of 3.
27 times square root of 3 inches squared. How many had this answer? For number 3. Okay, several of you. Some of you did not. Those who did not, questions. All right. I was about to say bringing back fond memories or bringing back nightmares, but this is stuff you learned on Zoom last year, too. You weren't even in class last year for this. Bless your heart. Chase, ditto, Melvin. So, anyway, we vaguely remember doing some of this via Zoom? Looking at it on a fuzzy computer screen or whatever?
Yeah.
All right. Either because of bad internet connection or just a camera that was subpar. All right, let's move on. Number 5. Read that for us while I erase the board, if you would, Ethan.
Yeah. A diagonal of a rectangle is 16 inches and it makes an angle of 30 degrees with the base. Find the sides of the rectangle and the area.
As soon as he said 30 degrees, class, we should have been thinking 30, 60, 90. We've got a rectangle, and we've got a diagonal, and the diagonal is 16 inches, but it says it makes a 30-degree angle with the base. So we're thinking 30, 60, 90. And it asks for, now it says find the sides. I said I want the area of the rectangle. How do I find area of a rectangle? Audrey? And the problem here is I don't know the B or the H. I don't know the base or the altitude, but since it's a 30, 60, 90, I know I can represent the base, class. Oh. X times the square root of 3. It's across from the 60. I know I can represent the altitude, class.
X.
Because it's across from the 30. And I know I normally would represent this hypotenuse 2x, but I already know it's 16, which means x, class, is 8. Well, there's my altitude. And that means my base is 8 times the square root of 3. There's the base. So what is the area of the rectangle, class?
64 times the square root of 3.
64 times the square root of 3 inches squared. How many have that answer for number 5? Several of you. Questions from those who did not get that. All right, let's drop down to number 15 over in the next column. Read that for us if you would, Chris.
Area of a polygon is 64 square inches. Find the area of a similar polygon if the two corresponding sides of the two polygons are as 1 to 2.
Similar polygons. Anytime I hear similar polygons and it mentions areas, Chris, I should be thinking
Oh, PL or PL over PL.
well, that's for any two parallelograms in general. We're talking about similar polygons specifically.
Is it A is to A prime as S squared is to S squared prime as P squared is to P squared prime?
Here we go. Areas to areas, side squares to side squares, perimeter squared is to perimeter squared. Now, they don't mention anything about perimeters, so we really didn't need to include this much. It tells me the corresponding sides are as 1 to 2. Well, that's a ratio, right? And if it's a ratio of corresponding sides, class, we call that the ratio of similitude. But the ratio of areas is not equal to the ratio of similitude. It's equal to the ratio of similitude squared. Good, Quentin. So if the ratio of the sides is 1 to 2, then the ratio of the areas, class, would have to equal 1 to 4. Square the 1 to 2. Does that make sense? Now again, they didn't tell us what the sides were, but it really doesn't matter because they would reduce to a 1 to 2 anyway. So we're going to plug in 1 squared, 2 squared, or 1 to 4. Now here's the only sticking point. It says the area of a polygon is 64 inches squared.
You don't know which one.
You don't know which one. So there's two different possible answers here. You could put the 64 here, in which case, anyone, the area of the other would be 256 inches squared. Or you could put the 64 here, in which case the area would have to be 16 inches squared. So two possible answers for this problem because they didn't specify which polygon specifically they were giving us the area. All right, well, our seniors have been enjoying this so much and enjoying all the memories flooding back from their coronavirus days, but we have to bid them adieu. All right, 10th and 11th graders, good to have you back. All right, questions on 15. How many had at least one of those answers? You got at least one of them. How many now recognize why we had to have two? All right, questions on this. All right, next page, number 18. And yes, sir.
Say you have something that has two answers and you only write one, is that half off on the quiz or test?
I probably would give more than just half credit, only because you've done pretty much all the work and you understood the problem. It would probably be more like on a 10-point question, like -3, probably not the full -5. Good question. All right, that said, on the test tomorrow, I don't have any. I don't think there are any, if my memory serves right, there aren't any where there's two possible answers, but I want to make sure we understood the reasoning why there would be there. Number 18, read that for us, Kendall.
The area of a rhombus is 66 inches and diagonals are in the ratio of 3 to 4. Found the diagonals on both sides.
All right, so area of a rhombus. As soon as it says that and it mentions diagonals, I should be thinking what formula, Genesis?
RH equals 1/2 to 1/2.
Absolutely. And since they give me the area of 600, I can plug that in for the RH. But they don't tell me the diagonals. They don't tell me either one, but they do tell me what about the diagonals.
Ratio 3 to 4.
In ratio 3 to 4. That doesn't mean they're 3 and 4. That means they're in ratio 3 to 4. How should I actually represent them?
9.
Class?
3x.
3x and 4x. Remember, they're in ratio 3 to 4, so just stick an x on there, 3x, 4x. Back to Genesis. If I were to multiply 3x and 4x, it would give me 12x squared. But of course, I need to take half of that to get,
6x.
and then to finish solving 2 more steps.
You would take the square root.
Not yet.
Oh, divided
The square is more attached to the x. It's almost like a part of the x's identity, more so than the 6. The 6 is just a friend. We'll get rid of the friend.
divide away the 6.
Divide away the 6 to get 100. And then we can,
Take the square root.
and of course we know the square root of 100 is 10. Now, that's not my answer. That's a means of getting the answer because it said find the diagonals. Well, the diagonals are 3x and 4x. So, Genesis, what are the diagonals? 30 inches? Yes, inches. 30 inches and 40 inches, but they didn't stop there. Then they said, find the diagonals, class, and one side. Well, how many sides does a rhombus have? How do we know which side they want? It doesn't matter, they're all equal anyway, right? So we've got our rhombus, and so we know one diagonal's 30, the other is 40. But what do we know about our diagonals, Genesis? They bisect each other. So if it's 30 and 40, the pieces are
30.
well, half of it, right? 15 and 15. And we also know, class, the diagonals are perpendicular. So how could I find the length of one side, class? Pythagorean theorem. Anyone able to do it in their head? 25 inches. What if it had asked for the perimeter, class? 100. There's 4 sides, all of them 25, so 100 inches. So we could have answered the questions of what are the diagonals, what's the side, what's the perimeter. We could have done any of those. In fact, we could have even answered the question, what's the altitude? Because a rhombus is a parallelogram, right? So while normally we would say rhombus equals a half d1 d2, and we had to start the problem, we could say that rhombus equals base times height, since we now know the base, like every other side, class, is 25 inches. So if the area is 600, and the base, like every other side, is 25 inches, what's the altitude? Find it. 24 inches. I mean, there's all kinds of stuff you could find. You see, the possibility is endless. Makes it really fun for me to write geometry tests with all the possibilities we have in a problem like this. Questions on number 18. All right, let's move down the line to 25. Read that for us if you would, Audrey. Class, as soon as she finished that problem, what should we be thinking? 30, 60, 90. Okay, so we got isosceles trapezoid, she said. And you said you gave us the shorter side, right? Right, Audrey? How big was the shorter side? 8 inches. You said the leg was 12 inches. So it says isosceles, class, that means both legs are 12 inches. And since it's isosceles, if one angle of the leg is 30, class, the other one's 30 also. Well, to find the area of a trapezoid, what's that formula, Quentin?
TR equals 1/8 times B plus B prime.
Right. Of the 3 things I need to find the area, class, I only know one. I know one of the bases is 8 inches, but I don't know the other one. I don't know the altitude. Well, thoughts? Let's draw us an altitude. Specifically, here or here or both, right? And now it's not drawn real well. It almost looks like a 45, 45, 90. So pardon my artistry, but it is a 30-degree angle, which means this side, this altitude class could be represented x. That also means since this is the 90, that makes this the hypotenuse, this should be represented 2x. And since this is technically 60, pardon the bad artistry again, down here, this piece is x times the square root of 3. By the way, the same thing's true here. X, 2x, and x times the square root of 3 right here. Well, if 2x is 12, plus what's the altitude? 6. That was easy. And what is this piece of the base? 6 times the square root of 3. And this piece of the base? 6 times the square root of 3. And this piece of the base? 8. So what is the length of my lower base? Careful.
20 times square root of 3.
12 times square root of 3 plus 8.
12 times the square root of 3 plus 8. Remember, these are similar radicals, they add. This is not a radical, you can't add it to the others. 12 squared root of 3 plus 8. So that's what we plug in here. Of course, we see that this is a plain old 8, and that's a plain old 8, which adds up to 16. So really, it becomes 16 plus 12 times the square root of 3. We could take half of 6,
Very good.
and we could distribute the 3 to get,
48 plus 36 plus 43.
and it's that many inches squared.
I hate that answer.
So
But it's perfectly accurate. Now, if you wanted to on your calculator, you could figure out what that is as far as like a decimal value, but that's how we're going to leave our answer because it's exactly perfect unrounded. Did anyone get this answer? All right. Does it make sense now how we could have, should have gotten this answer?
I got half of it.
All right. Questions? All right, a little review on adding radicals too, having to have similar radicals. Last one from the homework was number 27. Read that one for us if you would, Ethan.
The angle of a parallelogram is 60 degrees if the shorter side is 8 inches and the shorter diagonal is 13 inches. The area of the parallelogram.
Hit the desk, rejected, stuffed by the page. All right, as soon as Ethan got through, in fact, I think before he finished the first sentence, I already had a thought, class. 30, 60, 90, because it said 60. Now, I didn't hear the rest of what he said because I was busy missing the trash can. But I have a parallelogram with a 60-degree angle in it. And it says the shorter side is 8 inches, the longer side 13 inches, and it says find the area. Well, to find the area of a parallelogram, let's start with what formula? I'm sorry?
Shorter diagonal.
Oh, shorter diagonal is 13. Okay. Is
So we
this the shorter diagonal?
No.
Or is that the shorter?
That.
That is the shorter diagonal, 13 inches.
The other side is 8 inches.
And this is 8 inches, and that's 8 inches. Okay. Oh, always start with the formula. What's my formula?
PL equals BH.
PL equals BH. Problem. I don't know B, I don't know H, right? But
You can draw on this.
if I've got my altitude here, I can draw it, and with a 30, 60, 90, I have my hypotenuse class, 2x. I have this little piece of the base,
X.
and the altitude.
X times square root of 4 times
Well, so if 2x is 8, then x right here is
4.
4. That's not the base though, that's only part of the base, and this is,
4 times square root of 3.
well, I at least know the altitude. Agreed?
Agreed.
That's all I know. I don't know the base. I'm missing this part of the base.
Why not just do that one? The same thing.
Well, do I know that this is a 30, 60, 90 class?
No.
No.
Okay. Then do Pythagorean theorem.
Exactly. I know 1, 2 sides of my right triangle. I'm just missing the third side. Let's go Pythagorean theorem. C squared equals A squared plus B squared. Square the 13 class, 169. Now careful here. Square the 4 square root of 3.
16 times 4 root of 3.
Ooh, careful. You're squaring it. Not square root, squaring. 16 times. When you square a square root, you get the radicand. So 16 times 3 is just 48. Plus b squared. Subtract away the 48 to get
121.
121. Hey, that works out great because now b is just 11. So how long's the base? 15. 4 and 11. So what's the area?
60 times square root of
60
3.
times the square root of 3. Is that inches? Yeah, inches squared. Anyone get that answer for this one? Good, Chris. Questions from the rest of us? All right. Look at number 14 across the page. And they have a little picture there in case you forgot something. Read that for us if you would, Jamie.
Number 14.
Yes, please.
Find the length of the chord of a quadrant of a circle whose radius is 12 inches.
A quadrant. What is a quadrant, class? What is it?
1/4 of a circle.
1/4 of a circle. Right? And the way to form a fourth of a circle would be to have 2 perpendicular diameters. Now what that means is each piece of the diameter, class, is a radius, and all radii in a circle are
Equal.
so all these pieces are equal. But there's a chord in the quadrant, and it tells us the length of the chord, class, is.
Well,
Oh, we're finding the length of the chord.
Yeah.
Sorry. Finding the length of the chord, they tell us that the
Radius.
radius is 12 inches.
45.
12 inches, 12 inches, and 12 inches in class
45, 45, 90.
45, 45, 90, right? 2 equal legs in a right triangle, what's the length?
12 times square.
12 times square root of 2 inches. For number 14, do that in our heads virtually. Across the page, back again. Number 19. Go ahead and read that for us through part A, if you would, Quentin.
In triangle ABC, AD equals 8 inches. And AC equals 10 inches. Find the area of the triangle if angle A equals 60 degrees.
A, B, C. Drawing a picture helps. Tells me AB you said was
8 inches.
8 inches. AC was,
10 inches.
and you said their angle A was 60? Class, thoughts?
3069.
Is this a 30, 60, 90?
Doesn't not yet.
No, but we can make it one by drawing an
Altitude.
altitude, or specifically the altitude, to get a 30, 60, 90. Once again, this is the hypotenuse. We represent it,
X.
2
2x, which means this little piece is
X.
x, so it would be
4.
4. By the way, that means this piece is
6.
6. Not that we care. And how long is the altitude?
4 times square root of 3.
X times the square root of 3, so 4 times the square root of 3. What do I need to find the area of a triangle?
Base on height. Half of base.
Half base altitude. Well, they gave me the base, 10, if I drew it this way, right? And that's how I chose to draw it, was so the base would be 10.
5.
And the altitude's got to be 4 times the square root of 3. What's the area?
20 times square root of 3.
20 times the square root of 3 inches squared. Thoughts on how to process this? Part B changes it slightly though. You still have a 10-inch side and an 8-inch side. But now the angle, class, is
45.
45 degrees. So that when you draw your altitude, class, you now have a 45, 45, 90. Which means both the altitude and this piece would be represented,
X.
and the hypotenuse is,
X over 2.
at your seats, find x. Call it when you've got it.
4 times square root of 2.
4 times the square root of 2. You divide away the square root of 2, multiply top and bottom by square root of 2, simplify, or, in case you haven't figured it out by now, when you divide something by the square root of 2, this always ends up becoming a plain old 2, right? So you always just basically cut the number in half, and you always end up sticking a square root of 2 up there. Figuring out patterns makes your life easy, allows you to be
Efficient.
lazy.
I did that on the first day. I did that on the first day.
Efficient, okay, whatever, lazy. So we get 4 square root of 2 here, not that I care, and we get 4 square root of 2 here. I definitely care, because what's the formula for the area of a triangle, class?
T equals half of BH.
Half BH. Well, I know the B.
4 times square root.
Oh, careful. 10. The whole thing is 10, and I now know the H.
4 times square root of 2.
4 times square root of 2, so what's the area?
20 times square root of 2.
20 times the square root of 2. Which books aside, let's go ahead and practice another thing here. I've got a right trapezoid, meaning a trapezoid with one perpendicular leg. I know that this base is 39 inches. I know the altitude is 18 inches. I know this upper base is 2 feet. I want you to find the area of the trapezoid at your seats. Once you finish the first one, you go on to the second one. How many got 567 inches squared for the first one? 567 inches squared. All right, if you're good, move on to the next one. Questions on the first one before I erase? Anyone need me to leave it up here for just a moment? All right, I'll go ahead and erase. Working on the second. once you finish the trapezoid, I've got a parallelogram with a 60-degree angle. I've given you one side. I want to know the other side if the area is 180 meters squared. Check your answer to the second once you're finished. How many finished the second one and had it correct? All right, any questions on that second one? Anyone need me to leave it up for just a moment? All right, move on to the third one then at your seats. I'll leave that one up for just a moment. If you're finished with the second, move on to the third. There's a fourth problem up for you. All right, Genesis, second problem. Are you good to go on the trapezoid? Or question?
Which one is the oh, 6 times 2?
Right, that's the altitude, that's 6 squared root of 2. Now, the whole base is 15, so while there is a 6 squared root of 2 here, I really don't care because I already knew the whole base. It was this 6 squared root of 2 I needed for the altitude. All right. Are you good to go on that one now, or I'll go ahead and erase? Then once you finish the third problem, go on to this last one. If you're done with the third one, check your answer. How many got this answer on the third one? Those who are finished. Okay. Good. If you're not finished, keep working. You can check your answer momentarily. I'm going to leave it up. You can ask questions if you have any. For sake of time, pencils down. For sake of time, pencils down. Let's take a look at this one very quickly, just in case there were questions. We know the area, and I know the base, but I don't know the altitude. Well, you can find it really easily. PL equals BH, pencils down. So if 180 is the area and 20 is the base, just divide away the 20 to get the H. We know the altitude's 9 meters. That's not what I was asking for. I was asking for this side. Well, if 9 meters is the altitude, that's across from the 60. That's your x squared of 3. And that means that x squared of 3 is or equals 9. Divide away the square root of 3, you'll find that this little piece here that I don't care about is 3 squared of 3. But that allows me to find the 2x, the hypotenuse, which is 6 times the square root of 3 meters. You're good to go on the parallelogram. All right, then on the last problem here, I gave you a right triangle with a square drawn on the hypotenuse, and I asked for the area of the right triangle. Well, if you know the area of the square is 289, take the square root to get the length of any side, because SQ equals S squared. 289 then equals S squared, and when you take the square root, you'll find every single side, including the hypotenuse, is 17 feet. I gave you the base for this leg here was 8 feet. But remember, for the area of a right triangle, I need a half leg. Knowing only one leg isn't enough, we'll find the other leg, class, using the Pythagorean theorem. Should have found it to be 15 feet, and you can find the area then, class, to be 60 feet squared. How many had that answer for the last one? Again, some of you may not have made it all the way there. Questions on it now that we've seen it worked.
Wait, how'd you get 15? I didn't get the right answer, actually.
Okay, so remember C squared equals A squared plus B squared. We know C is 17, so that's 17 squared. We know that A is 8, so 8 squared plus B squared. 289 equals 64 plus B squared. Subtract away the 64 to get 225. And then when you take the square root, you get the 15.
I got 68 because I treated the 17 as B.
Okay. Question? All right, clear desk except for clean sheet of paper, pencil, and calculator. Clean sheet of paper, pencil, calculator, everything else away. Papers for a cover sheet. Do not write anything on your piece of paper. Sheet of papers for a cover sheet. Please don't write anything on that piece of paper. You'll take your quiz directly on my quiz copy.
Calculator, please.
There's not a place for you specifically that says name, but there is space at the top of the paper, much like our construction quizzes. So if you would, put your first and last name at the top of your quiz copy and today's date, which is 5/11. 5/11/21. 5/11/21, today's date. Pretty straightforward on the quiz. Numbers 1 through 7, answer those questions by writing those formulas. And then for numbers 8, 9, and 10, follow those directions. Make sure you leave your answers not in decimal form, but either fraction form or radical form as necessary. And of course, show your work to receive partial credit. All right, using that extra sheet of paper as a cover sheet. Cheaper to get it out lost and found than it ran. be finishing up in the next couple of minutes.
In this calculator, how do I put something into a fraction?
Just another minute or so to be finishing.
Just put that down.
At this time, if you would go and pass your quizzes forward. I'm going to pass your quizzes forward. Because we're recording, I'm not going to grade them in class. What I will do for you is give these to you right after your next class. So you're going to be in Bible class next hour. I'll have a free period. I'll get these graded and back to you. If you would, go ahead and direct your attention over here to the screen. We do not, unfortunately, have time to actually work all of these problems as a class. Normally we would, okay? I want to just kind of run over the problems so you can see what they look like. I'm going to give you a copy of this when I give you back your quiz. So I'll give you a printout of these various problems, which you can work if you want the practice. If you'll work them, show them to me. I'll be going over them later. But, so we've got, let me go back up here. Rectangle with a base of 36 inches and an altitude of 2 feet. Find the area. Two rectangles, a ratio of 5 to 3. Base and altitude of the first, 8 inches, 5 inches. Base of the second, 6 inches. Find the altitude of the second. Hopefully you're thinking how you would solve these as I'm going over them. Area of a triangle, 45 square feet, altitude 15 feet, find the base. Bases of trapezoid, 5 inches, 13 inches. Area of trapezoid, 63 inches. Find the altitude. These are some of the more basic problems like you'll see on the test. Area of a square, 36 square yards. Find the length of the diagonals. Diagonals of a rhombus, 7 inches, 10 inches. Find the area. Legs of a right triangle, 6 centimeters, 8 centimeters. Find the area of the triangle. Legs of a right triangle, 10 inches, 24 inches. Find the area of a square constructed upon the hypotenuse. Perimeter of a square, 32 inches. Find the area. And no, perimeter and area are not going to be the same. Perimeter of an equilateral triangle, 39 feet. Find the area. Similar polygons, corresponding sides, 12 inches, 15 inches. Area of the first is 160 square inches. Find the area of the second polygon. Okay, so these are some of the problems. I'm going to give you all a copy of it. You do not have to do it, okay? It is not homework, okay? But it's available to you if you want to do it. What I'm going to do is I'm going to record a YouTube video of me going over all of the answers. So what I would suggest for extra practice would be that you'd work the problems, then watch the YouTube video, which I'll very quickly go over the answers and how I obtained them. And that'll be extra review for you if you need it. Now, if you feel like, no, I got this. I am ready for this test. I don't need no extra practice. Talk about practice? I'm Alan Iverson. I don't care about practice. Anyway, but if that's your attitude, I don't need the practice. I'm good. That's, and maybe that's not necessarily even arrogance. Maybe it's just confidence. You're ready. That's fine. You don't have to do it. But I'm going to give it to you anyway as an option, and I will be recording the YouTube video of me going over those problems. So that'll be a little extra review if you feel that you would benefit. So after Bible class, you're getting back your graded quiz, and you're getting a handout, which you may work, and if you do, YouTube video. Does everyone know how to find my YouTube channel? We've been there often enough. Is anyone's going to need the link emailed to mom or dad? Anyone say, I need the link because I can never find your YouTube channel. All right, so all of you good, excellent. All right, that'll be uploaded then by this evening. All right, well, when the bell rings, you are dismissed. Test tomorrow. Again, no official homework, but there is extra practice if you want to take advantage of it. Have a wonderful rest of your day.